Hello everyone, in this video we're gonna solve 2025 AP Calculus BC free response question number 6. The Taylor series for a function f about s equals 4 is given by this one and converges to f of s on its interval of conversion. Question A. Using the ratio test to find the interval of convergence of Taylor series for f about s equals 4. Alright, so we have the ratio test, which means limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity is the same thing as limit when n approaches infinity of this guy right here, a sub n plus 1, which means s minus 4 raised to the n plus 2 over n plus 2 times 3 raised to the n plus 1, right? Now divide by a sub n, which means you divide by this one, right? So you're gonna multiply by its reciprocal, right? So it could be n plus 1 times 3 to the n over s minus 4 raised to the n plus 1, right? Now we're gonna simplify this one. S minus 4 raised to the n plus 2, and this one, it turns out to be s minus 4 left here, right? Now this one right here, 3 raised to the n plus 1, I just write 3 raised to the n times 3, right? So this guy cancel out, right? So I have limit when n approaches infinity of absolute value of s minus 4 over n plus 2 times 3 times n plus 1. Now when n approaches infinity, n much greater than 2, so you just ignore this one, right? This one, same thing, you just ignore 1 right here, right? So you have n on the top and n on the bottom right here, cancel out, right? So you have absolute value of s minus 4 over 3. Now this guy must be less than 1. Alright, so you're going to multiply both sides by 3. So you have absolute value of s minus 4 less than 3, right? It's the same thing as negative 3 less than s minus 4 less than 3, right? Add for 3 sides. So you have 1 less than s less than 7, right? Now we need to check the endpoints, right? Now s equals 1. We have substitute 1 for s into this guy right here. So this guy is the same thing as 1 minus 4 is going to be negative 3, right? Now we can split this guy. So it's going to be the sum of negative 1 raised to the n plus 1 times 3 raised to the n plus 1 over n plus 1 times 3 raised to the n when n goes from 1 to infinity, right? Now we need to simplify 3 raised to the n on the top and bottom, right? So we have the sum of 3 times negative 1 raised to the n plus 1 over n plus 1 when n goes from 1 to infinity. Now we're going to take the limit of this guy when n approaches infinity, right? So limit of 3 over n plus 1 when n approaches infinity. This guy actually 0, right? So by the alternating series test, the series convergent, right? Now we're going to check for s equals 7. So we have summation when n goes from 1 to infinity. 7 subtract 4 is going to be 3, right? So we have 3 raised to the n plus 1 over n plus 1 times 3 raised to the n, right? Now this guy is the same thing as the summation n go from 1 to infinity. 3 raised to the n times 3 over n plus 1 times 3 raised to the n, right? And then we need to simplify this one, right? So it's going to be the sum when n goes from 1 to infinity of 3 over n plus 1, right? Now we take the limit of 3 over n plus 1. We compare with 1 over n when n approaches infinity. So it's going to be limit of 3 over n plus 1 multiplied by its reciprocal. So it could be n over 1, right? So it's going to be 3n over n plus 1 limit when n approaches infinity, right? And it's going to be 3, right? Because when n approaches infinity, n much larger than 1, right? So I just ignore this one, right? So you have 3n over n. Now cancel out n. The answer must be 3, right? And you know that 1 over n is divergent by p-series test. So by limit comparison test, the sum when n goes from 1 to infinity of 3 over n plus 1 divergent. Then you're not going to include s equals 7, right? So we're going to combine the condition right here and s equals 1 right here, right? Because it's convergent. So finally, we have the answer 1 less than equal to s less than 7, right? B. Find the first 3 non-zero terms and the general term of the Taylor series for f prime, the derivative of f about s equals 4, right? So basically, you just take the derivative of this one, right? So we have f prime of s is going to be derivative of this one, bring 2 to the front, right? So we have 2s minus 4 power of 2 minus 1 is going to be 1, so we don't need to write, right? Over 2 times 3, right? Minus, bring 3 to the front, so right, 3 times s minus 4, 3 minus 1 is going to be 2 over 3 times 3 square plus 4 times s minus 4 power of 3, right? Over 4 times 3 cubed, right? And the general term is going to be n plus 1 times s minus 4 right to the n, because n plus 1 subtract 1 is going to be n, right? Over n plus 1 times 3 to the n, right? You just leave the answer like this. You don't need to simplify, right? Now question C. The Taylor series for f prime described in part B is a geometric series. For all s in the interval of convergence of the Taylor series for f prime, shows that f prime of s equals s minus 4 over 7 minus s, right? So part C right here, we just took the derivative of the function f is going to be right here, right? So we have f prime of s is going to be the sum of n plus 1 times s minus 4 raised to the n over n plus 1 times 3 raised to the n. when n goes from 1 to infinity, right? Now, you need to simplify this guy, right? So it's gonna be the sum of s minus 4 raised to the n over 3 raised to the n when n goes from 1 to infinity, right? Now I can combine these two guys right here, so I just write sum when n goes from 1 to infinity s minus 4 over 3 raised to the n, right? Now if n equals 1, I have s minus 4 over 3 plus n equal 2, does that mean I have s minus 4 over 3 square, right? N equal 3, s minus 4 over 3 cube, right? Plus etc. plus s minus 4 over 3 raised to the n, right? Now, observe that this one is a geometric series, right? With a common ratio, it's going to be s minus 4 over 3, right? Because you just multiply by s minus 4 over 3 each times, right? Alright, so we have the common ratio r equal this one, right? And the first terms right here, right? Now, we have the formula to calculate the sum of infinite geometric series. It's going to be given by the formula a1 over 1 minus r, right? So it's going to be s minus 4 over 3 over 1 minus s minus 4 over 3, right? Now, I need to multiply the top and bottom by 3. So I'm going to simplify 3, right? So it's going to be s minus 4 over 3 right here. I distribute over here, so I have 3 minus s plus 4, right? So it's going to be s minus 4 over 7 minus s. And this is f prime of s, right? Now, let's move on to question D. It's known that the radius of convergence of the Taylor series for f about s equals 4 is the same as the radius of convergence of the Taylor series for f prime about s equals 4. Does the Taylor series for f prime described in part B converge to f prime of s equals s minus 4 over 7 minus s at s equals 8. Now, since the radius of convergence of the Taylor series for f about s equals 4 is the same as the radius of convergence of the Taylor series for f prime about s equals 4. So, s greater than or equal to -1 less than 7, which you found in question A, right? Now, since s equal 8 is outside of this one, right? So it's going to be no. Now, in question C, we just found the common ratio of the infinite geometric series. It's going to be s minus 4 over 3. We got it right here, right? So we substitute 8 right here into this one. So we have r equals 4 over 3, which is greater than 1, right? So it tells us that f prime of 8 equals the sum when n goes from 1 to infinity of 4 over 3 raised to the n is divergent, right? Because r equals 4 over 3 greater than 1, right? So you need to say the Taylor series for f prime described in part B does not converge to f prime of s equals s minus 4 over 7 minus s at s equals 8. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings, as the chemicals they take us higher. The night's young, it has just begun, as she puts her hand in mine.